Okay. So hopefully you did all right on that. I'll try to get those back to you, or I will get those back to you by Monday. Everybody with me? I'll get it back to you by Monday. And I'm still seeing a lot of people who don't get it in my other class who just aren't getting it. Most people are getting their rules better, although I wasn't able to check all of them. Just on that spot check, it looks like that's a little bit better. But guys, if you're struggling with this, it's not a big deal to come get help from me. Just do it. Okay? Again, you guys tend to do a little bit better than the other class historically, so maybe you guys are all in great shape. No disrespect to the other class if you're looking at it. But anyway, make sure that you get help. We're going to review all next week, but at some point you got to go, okay, I just don't get it. And let me point out exactly what it is. Because thinking you know what you're doing, you can look at the keys and go, oh, it's just a careless error. It's not. It's a conceptual error that'll kill you on your AP test. Because most of these questions are not show your work. They're just multiple choice, and you're going to be right or wrong. And one little number throws the whole problem out. So let me give you an example of what we're going to do. Two things today. One is a variation on U substitution. I call it ugly U substitution because it is a little uglier version of what our U substitution is. Now, a couple of things I want to throw at you first. Would you need U substitution for a problem like this? Anybody got an idea what you would do with this? Multiply it in? Because a root x, a single variable under there, I could rewrite that as what? X to the 1/2. And if I rewrote that as an x to the 1/2, then I could just distribute it in, and I would get what? Like bases, add exponents. And that times that is just an x to the 1/2. And what rule could I use now? Just the power rule. So I could go, oh, well, x to the add 1 gives me 5/2 divided by 5/2 multiplies by 2/5. And then here, x to the add 1 gives me 3/2 divided by 3/2 multiplied by 2/3. So when there's a single variable underneath a radical, I can just multiply it in, even if it was in the denominator. Like even if this problem started out with a root x in the denominator, couldn't I change it to an x to the 1/2, move it up, and make it an x to the negative 1/2 in the numerator? Right? Even if it started down there, and then move that in. Those kind of problems aren't issues. Here's where we run into trouble. What happens when I have something like this? And see, now I don't have a single variable in the denominator. It's not a single square root of x. Right? So, and by the way, I can't go root 2x, root -1. That's not math. Okay? So I don't have that as an option. So a lot of people go, oh, we'll do U substitution. Because right now this is not a rule. And normally when I see a radical, I think, oh, it's probably a power rule, right? Change it to a 1/2 power. It's a 5th root, like you might have seen on your quiz. Change it to a 1/5 power. Make a U substitution if you need it. And it usually works out great. But the problem is, if I were to call that my U, then my du is just 2dx. And even though I don't have a problem right here, plugging a 2 in there and balancing it with a 1/2, when I go to circle my u and my du, what's going on there? I have this extra x in my problem that was not accounted for. So if this happens and all else fails, like all of your other rules fail, you've tried every possible U situation, and every single time you end up with this extra variable in there, that's where what I call ugly, it's not the people don't call this, it's just U substitution, but it's an uglier U substitution will occur. So what's going to happen here, if I replace that with U and that with du, which is great, this also has to end up being a U value. So what you do is you go back to your U expression and you solve for x and replace x with what you get. So what would happen right here if I went and solved for x right here what do I get? What? No, solve for x. What do I get? It's equal to u, right? So add a 1 to the u, and I get u plus 1 over 2. So x is u plus 1 over 2. Are y'all with me on that? So if I solve for x, I get u plus 1 over 2. I'm going to replace x with this. Now, at first glance, you think, how is that helping something? Because now, watch what happens when I do my complete substitution here. I'm replacing that with this. I'm replacing the radical, a step under the radical, with a u, which gives me a square root of u. And then I'm replacing the 2x there with du. And right now, that doesn't look a whole lot better than it did to start. But the thing that does make it look better is it's a monomial under the radical. And if it's a monomial under the radical, like before, what am I allowed to do? Make it a 1/2 and just multiply again. So that's the advantage. This is what you do. In almost all of these problems like this, I'll show you another one after this, you're going to see a radical in there. And you're going to try use substitution, and it's just not going to completely dissolve or get rid of all your x's. So as a last-ditch effort, I try this. So here's what I'm going to do just to clean it up a little bit before I do this. I'm allowed to pull out coefficients. That 2 on the bottom is kind of like a 1/2, isn't it? So I'm going to pull that 1/2 out. That gives me a 1/4 on the outside. And I'm left with a u plus 1 and a u to the 1/2 power du. And that I can distribute it. So currently I'm at 1/4. U, how would I do with like basis again? When you multiply like basis? Add the exponents. So now, when I take my derivative, I get 1/4 u to the 5/2. And when I divide by 5/2, I'm multiplying by a 2/5. And then I go plus, and by the way, all of this is going to have to get distributed into by that 1/4. So then the next u becomes u to the 3/2. Divided by 3/2 is multiplying by a 2/3 plus a c. And then my very last step is to take that 1/4 out front and distribute it in and replace that with your u value. So I got to go all the way back to get my u. So I end up with 2/20, which is 1/10, u, which is 2x minus 1, all of that to the 5/2, and then plus 1/4 times 2/3 is 2/12, which is 1/6, u to the 3/2, and then of course 1/4 times c is just another constant. And if looking back at this problem, remember the red flag for you of maybe that this is when this will happen is when you see a square root in there, right? And when you go to do the u substitution, that x is still left. Now, look what would have happened had that been 2x squared from the start. If this had been 2x squared from the start, what would your du have been on this problem? Your du would have been what? 4x dx? And you would have come up here and said, well, 4, 1/4, but there's 4x dx. I didn't need to do all this junk, right? So the approach is still the same. When you see more than a single monomial under a radical, almost always you're going to be looking at a situation with the u substitution. But if that x is not sucked into the dx, then you go, well, I do that second u substitution, essentially, by replacing the x. Go back to this right here, replace the x with what it's equal to. But in this case, it wouldn't have been necessary. But in the other case, it is. Here's a second problem like that. You need to see just something else. It's a little different, but the same thinking. So once again, you have a binomial under the radical. And And normally when I see a radical, I think a power rule, right? It's a power on the bottom, but I know a power on the bottom can be moved up and made a negative exponent. So I'm thinking, oh, I bet that's u to the 1/2, which will end up being u to the negative 1/2. So I'm thinking, well, let me try a u substitution. So if u is x plus 3, then my du would be dx, right? And the problem is, and you can see it right here, there's my u, du is dx, there's my du, but I've got this extra x sitting there. And I don't know how to account for that. I could try doing other u substitutions with other things, but I can't get rid of all the x's with my substitution. So at that point only, what do I do with this x? I set that equal to x, which gives me x equals u minus 3, and I'm going to replace that x with a u minus 3. And of course, I'm going to replace the other stuff as well. So here we go. I'm going to do all the substitutions now. So this gives me, in the numerator, 2x, which is a u minus 3, minus 1, all of that over the square root of u du on the outside. Now I'm going to clean it up. And again, on all of these problems, you're almost expecting to end up with that single radical. You're going to expect to change it to either a 1/2 power, 1/3 power, whatever it is, and distribute it in. So right here, the numerator ends up being 2u minus 6 minus 1, so 2u minus 7. You tell me, would you rather deal with a u to the 1/2 in the denominator and then think this way? How do I divide by like basis? Or would you rather think this way? A 2u minus 7 and take that u to the 1/2 in the denominator and make it a u to the negative 1/2 in the numerator and distribute it in. Would you rather think this first way or the second way? Most people say the second way, but if you're looking at the first way, you go, well, like basis, subtract 2u to the 1/2, and then on the 7, I just get 7 over that, which is 2u to the negative 1/2. So you get that either way. Here, like basis, add exponents, 2u to the 1/2, negative 7u to the negative 1/2. But in my experience, most people would rather see that. And they all kind of feel this way. And you've already had a bunch of problems that started out looking like this, except there were x's, but you would see like 2x squared minus x plus 1 over root x. And hopefully you've been taking that root x and making a root x, a x to the negative 1/2 and distributing it in. And then are we good at this point? So right here, 2u to the 3/2 multiplied by a 2/3, replace the u. And then here, minus 7u to the 1/2, 5 by 1/2 multiplied by a 2, plus c. And since I didn't have any number up front, I don't have to distribute. By the way, I didn't count off on this quiz, and I won't probably till your test. But on your test, start simplifying these numbers. Okay? If you end up with a 1/2 and a 1/4 out front, and quit doing this. Some of you are still going, like you'll write 3/2 and then you'll divide by 3/2. Don't do that, because all of these problems are most all of them are going to be multiple choice, and you need to be able to get to where you can see what they're going to have. So if that's right, if you wrote that, I'm probably going to take off a 1/2 point for not simplifying it. Change that 3/2 to 2/3 and then clean that up to a 4/3. Are y'all seeing this? Again, maybe one problem on your test, like a 4 or 5 point problem. It's not going to be zillions of them. It may or may not show up on an AP test. I haven't seen one in a couple of years, but it does occasionally. Basically, it's U substitution, but it's what you do last ditch effort if you still have a variable that doesn't match your U's after a substitution. You don't know what to do with it. All right? Okay, second and final thing I want to do today is, what do you do in a situation? Okay, first I'm going to give you a situation where I hope that you know what to do. Like, what if I gave you this? and said integrate, what would you probably do, and then tell me why? Anybody? Okay, tell me why you picked the 3x squared minus 5x. And what, before you even did that, what made you lean towards it? It was a higher power. And most people think that way. Grab the one with the higher power. Okay? And you'll notice the highest power is in the denominator. So she said, do this. Pick the one in the denominator for a couple reasons. One, it's the highest power, but also because when I take my du, not only do I get exactly that, but also I get a lower power that's completely in the numerator. Right? That's not 1 over 6x minus 5. That's a numerator value. So let me ask you a question. What would you have done then in this situation? Does this u substitution still work if it was this? Because right here, if I call that u, which is the highest power, then I get this, but that 6x minus 5 is in the numerator. This is like a 1 over 6x minus 5. This would not work here, would it? So what do I do when the denominator is not bigger in the denominator? Sorry, when the power is not bigger in the denominator, but rather it's the same or even bigger in the numerator. And that's what we're going to talk about today. So these are usually really easy to identify. So here is your first of maybe one, maybe two. We'll see what we can get to. So you're taking your quiz, your test, you stumble into this problem. You're kind of in a habit of grabbing the highest power, but then you go, wait, if I get the highest power, that's the numerator. If I take a derivative, I'm also going to get a numerator value. How am I going to deal with the x's in the denominator? So you're going to actually, to make it better, you're going to have to actually do long division before you get started. Now, do you remember doing long division in Algebra 2 and Pre-Calc? I hope is that you do, but I'm going to give you a reminder, okay? So when you do long division, do you remember what you ended up with? You ended up with a bunch of individual terms, like maybe an x squared, maybe an x, maybe a constant, and then you ended up with a fraction, right? And do you remember what your fraction looked like? Wasn't the power always smaller on the top than the bottom? If it wasn't, then you weren't done dividing. So the whole point of long division is to do it so you end up with a fraction where the power is smaller than the top. And then the other terms are easy to deal with because they're just monomials with powers. So like if I ended up with something like, when I do the division here, if I ended up with something like x squared, if I end up with something like x squared plus x minus 2 plus, I don't know, 2x minus 1 over x squared minus x plus 1. Isn't that totally something I could end up with when not do division? So I just basically replace that with this, and I integrate that. Now, this is not what you end up with, although that might be close. But this is not what you end up with. But the upside is, look, this part's going to be easy to take the integral of. That's going to be easy to take an integral of. That's going to be easy to take an integral of. So when you get it to this point, all you end up doing is integrating each individual part separately, and then you get down to a fraction that you can deal with because now the denominator is smaller than the numerator has a smaller power than the denominator, and a u substitution should work. So let's take a look at this one. So I look at this, what's the red flag? Power is either the same on the top and the bottom or bigger on the top. Those are the red flags for you. So here's long division so that this will happen. Now who remembers anything about long division? You do what? You do one variable at a time, but do you remember what you do when you're writing it out? What happens if you're missing a power? You got to put a 0 to hold that place value. So you can see I'm missing some stuff on the top. So I'm going to put a 0 in there for the x cubed, a 0 in there for the x squared, but I do have the x term and the constant. Now when I go through there, be careful. It's really easy to make a sign error, careless error, copy. Last period, I copied the problem wrong. So make sure you copy everything down right. I actually put a plus there. So be careful on that kind of stuff. And then start the long division. So if you forgot long division, this is the process. You take that right there and you say, what do I multiply that by to get that? And the answer would be x squared, and you put that up top. And then whatever you write up top, you're going to multiply it by all of that and then line up your answer. So x squared times x squared, line that up under the x to the fourth. X squared times negative x, line that up where the x cubed would be. X squared times x, line that up where the x squared would be. And then what do? Change your signs, right? Because that's subtraction. And then subtract and write down what you get, which in this case would be a positive x cubed, negative x squared. And like with all long division, drop the next term. And then repeat your process. X squared times what gives me x cubed? Write that single x up there, and it's really not that important on top, how you line them up. And then take that x and multiply it by everything. X cubed, negative x squared, positive x. Once again, you're going to subtract. I do that by changing my signs. And then this time you kind of got lucky, because not only the x cubes, but also the x squareds cancel. And when I drop the next term, I'm done though. And why is that? Because my last highest power is smaller than what I'm dividing by. And that's my goal of turning this fraction into something I can function with. So what am I left with? 2x minus 1 on the top over the x squared minus x plus 1. So this I'm going to use to replace this. So here we go. I got an x squared, an x, and a 2x minus 1 over an x squared minus x plus 1 dx. And that I should be able to integrate. Why? Because if I'm adding or subtracting, remember, we can integrate each part separately. So the first part, child's play. The second part, child's play. And the third part, I should be able to get away with a nice, neat U substitution. Now, if this is a calculus class in college, at Vandy or someplace like that, they'd probably find a way to stick it to you again. But in this case, look how kind they were. So I'm going to actually do a U substitution for the last part. And by the way, you could do individual U substitutions if you need it, but you want in this part. So I'm going to let U equal what? Right, the denominator, which is what I normally like doing. X squared minus x plus 1. My du then ends up being 2x minus 1 parentheses dx. What a gift. Look at that. There's my u. There is the du. I don't even have to make an adjustment on this one. So now I have to integrate the last part, 1 over u du. So what does that leave me with? X cubed over 3 plus x squared over 2 plus, and what's the rule? The natural log of the absolute value. And each one of these had a c, so they all add up to be some c, and then don't forget to plug your u back in. You see that? So in my opinion, these problems aren't that awful if you know long division, and you can be careful there, but they can feel awful. Yeah, I'm not getting through another one in 2 minutes. I don't see it. Are y'all with me? Okay, remember, we switched Wednesday and Friday, so tonight we're doing Wednesday's work, and that is it as far as integration for our class. So at this point, you're going to have 4 days next week to practice, although we are taking a quiz, I think, Thursday. But practice. Go home tonight and really figure out what you don't know so you can come in here and see me and ask me. I really want this to be a A, an easy test to grade. That will happen if you do well. Okay?